Thank you for downloading Lvl Exporter. If you haven't installed it, well, first you need to download it, so download that first, and then go to Edit, Preferences, the drop down, and then Install from Disk, and then just select the zip file from wherever you downloaded it. So then just hit Install from Disk down here. Should be pretty simple. Now, to find it, it should be in your N panel, so in a 3D viewport, hit N. And if you have a lot of stuff like me, you might have to search around for it, but it should be on one of your add-ons on your N panel here. So the basics is that Lvl Exporter works fairly simply. You have a file name and an export path. The file name is what you want your file to be named as, so pretty pretty simple. So we're going to name it test file. You don't need any extensions, don't need .json, .xml, just whatever you want to name your file, that's all you need. And then your export path, you can type it, but there's this folder icon, which makes it way easier. I'm just going to put it in my home directory. And then it's simple as that. You just hit XML to export to XML. You'll see down here at the bottom, XML level exported to wherever your path is. Same thing with JSON. And that's really it. Now, if you want to see how it worked, we can see, look, now I have a test file.json and a test file.xml. I can open those with Visual Studio Code. Let me open this one too. I want to open it with something else. I think code is easier to read. So as you can see, it just exports everything in your scene file with the data it needs. And let's go back to the JSON here. I feel like the JSON's easier to read, but it exports it into different categories, which I will show you right now. Let me just collapse. So you'll see there is 5 main categories. Meshes, so if you're familiar with Blender, yep, anything that's a mesh will get exported into this category. So our lone cube in our default scene is here. Colliders, I'll talk about that in a second. Lights, any light will appear here. And spawns, which like colliders, I'll talk about that in a second. And we have the camera. So if we go back to our default scene, we can take a better look at what, let me get out of that. So back here, we'll see, this is, let me close the end panel actually. You'll see it exported our cube, our camera, and our light. Now, the information it exports is mainly the location, the rotation axis angle, the rotations in both radians, which is what Euler radians, and Euler degrees, which is more degrees. And you can do quaternions. Make sure that when you do that, you'll probably want to switch over to quaternion mode in the rotation mode. So you can do either or. If you're switching back and forth, you may have some problems. You might just have to re-export the file to see it correctly. But like right now, you're like, okay, well, these are all zeros and ones because it's the default cube. But let's say I rotate it and move it up a bit. And let's move it on all axes just a little bit. If I go back to, where did I put a Lvl Exporter? Down here. If I go back and export those and go back to code, you'll see all the information updated on both of these. So and you can take a look at your item and you'll see, okay, we got 0.6, 0.5, 0.9, 6.5, 0.9, got all these decimal digits out there, or rotations. Where's the rotation? See, so these are in radians, so you're like, if you look at this, it shows it in degrees, so you might be a little confused if you look at these and you're like, those don't match up, because they match up down here. but I decided to include the radians as well, in case whatever you plan on using it uses radians. So you got 2.82, 469, 50, it all lines up, you see. The Quaternions, if you're not in Quaternion mode, it's just gonna not really, I don't even think it shows up in the item panel here by default, so yeah, unless you're in Quaternion mode, those aren't really gonna display. We can try switching it real quick. We'll have to do another export. What am I doing here? Let's go down to Lvl Exporter. Let's just do the JSON this time. And you see now the Quaternions are now updated. It'll keep, I think it will keep whatever previously is you set here, so these won't change, but the Quaternions will. I personally like to leave it in XYZ Euler is usually what I keep it in. So let's re-export that JSON file. And yeah, I think, yeah, like it also just keeps the Quaternion, like if it hasn't changed, it will keep it whatever it was before. But yeah, to export Quaternions, you're definitely going to have to switch to Quaternion mode to get that scale. Well, we didn't scale it, so let me scale it up a bit. Maybe skew it on an axis. We'll see. So let's do that again. See, look, our scale updated. So we got 1.5, 1.4, 1.68. Looks all good. So that's the basics of how it works. Now, lights do have a couple other parameters that meshes don't, which is mainly color, power. This one has a radius and type. So the type is like a point light, a spotlight, a area light. Just kind of help you when you're exporting. Like say you're going to parse this file in 3JS or something, you can generate lights based off in your code based off of what type it is. Now the color will update to, this is like the standard like white light, but every software handles colors and powers differently, so you might have to account for that the way whatever software package you're going to use this data for might be different than Blender's. Like I know the power, I'll show you an example later, but I wrote a file in Panda 3D to test out the parsing and the data that was exported from this, and the power of Blender doesn't exactly line up with the power Panda 3D does light intensity with. So like this info is there, but you might have to like finagle with it a little bit. It might be more of a starting point than just like a plug and play solution. And back to this data. This data is based off of whatever units you have set up in Blender. So if you're working with meters, it's going to export it in meters. If you're working, with degrees, well, I've got it set up to set up radians and degrees, but what I'm saying is like for your scale and location, your dimensions, like they're all going to export in meters if you're using meters, if you're using feet. So keep that in mind when you're setting up a scene in a different software package like 3GIS or something, because if they use meters or if they use feet or something like that, and you have it different, your scene is going to end up, like if you write a parser to parse through all the data and set it up, it's going to look different. The spacing and everything might look wrong. So keep that in mind. I didn't need to collapse that. Camera's pretty much the same. You do have the type again, but camera based, so perspective, orthographic, or something like that. Got focal length, clip start, and clip end. Once again, different software handles that a little bit differently, so might not be plug and play, but you can give it a shot. If anything, I wrote this to be more of a layout tool than a 100% like get it up and running. Like you just plug and play, because you're gonna have to write code anyway. This isn't like an exporter in this. It exports data, not like a scene file that you can just throw into like whatever you're using, and it'll just pop it up. I wrote this to make it easier to work with like game engines that don't have an IDE or a 3D level editor or something like 3JS, where it's like you want to make interactive web content, but you know it's a pain to just write it all by code. And like I have imagine this is a simple scene, but like I would have to write, all right, load the cube in, put it in here at these coordinates, at this rotation, do that for this. And then imagine if you have like, you know, a million of these with like different rotations. Like it would get, and just imagine like if this whole scene was filled, like it would get really busy really quickly and really annoying to set up anything other than like the most simplest of scenes. So I wrote this to help out. But back to the tutorial. So you might be like, how do I generate colliders? How do I generate spawns? Well, one, these are more for game development. You know, if you're just creating like little 3D scenes that you want to lay out somewhere and display, you probably won't need colliders or spawns. But for my personal use, and I figured other people would find it useful. I was like, oh, okay, well, maybe I'd write that in. So to make a collider, let's just use this cube that we got left over. It's pretty simple. You just add COL underscore to the beginning of any mesh object. It has to be a mesh object. So any one of the objects here, or if you create like a 3D model, like you could edit this and, you know, pull it and, you know, it would still be considered a mesh. You know, if you started with the cube and you made like a 3D model, if you just made like some plane and then started extruding, like anything that's considered a mesh in Blender should be able to be used as a collider. Now, once again, this is more for working with code. So like it's not going to literally export a collider for you. It's more to help you set up colliders based off the info it gives you, the data. So let's export, I keep forgetting where it's at, that, let's do XML as well. So now in our colliders we have call cube 0.001, has like all of it, even has the dimensions. I found that the dimensions can kind of help you, you know, these dimensions down here can help you set up colliders better. It's not like perfect, but that's what I found helped me when I was setting up colliders in the example. I'll show you later. So that's pretty much how you set up a collider. And now one thing I don't know if I mentioned, but when you export an XML or JSON file, it's going to take the name of the object in your scene view. You know, so whatever it's named over here, that's what it's going to be named in the data. So if you're not in the habit of naming your objects properly in Blender, maybe it's about time to do that. All right, so the final category we have is spawns. So to show you how to do a spawn, it's very similar, but instead of meshes, you have to use an empty. I decided to use empties because spawns aren't like really tangible objects. You know, I wanted spawns for like maybe a spawn point for a character or like some smoke or whatever, like particle effects, you know, just something where it could be spawned out of, which is mainly just location data. So I felt like you didn't really need like a cube or something to, you know, represent that. But just like colliders, you need to write spawn underscore in the front of the name of the object. We can go back to Lvl Exporter, export that, and then boom, got our spawn empty, has the location. Pretty much just gives you almost all the same information that a mesh would give you. Sorry, but you know, it sorts it into the spawn, which like technically you could probably write a parser that just could go through all the meshes and figure out what's a spawn. Like I could have wrote it that way and maybe add a tag, like add a new field that's just tag and like, is this collider spawn? But I felt like it was easier just to make a separate category, object that would, just have spawns in it. So you can just write your parser to look through the spawns or look through the colliders and figure it out. All right, so as an example of it, I did create a file. I should have titled it. I just called it untitled. Not the best name, but it created this test file for Lvl Exporter to try it out, and it's just a little bit more complicated to show you. Like I got all these different shapes, objects. These like transparent ones are colliders. There's also one around the cube here that I'll generate in code. And then you have these like spawn points here is where I'm going to generate some smoke, and there is some lighting going on. You might see like these, I made these colliders transparent so you could actually see the object behind it. But this is generally like how we want our scene to look in what we're exporting it out of Blender. I use Panda 3D for an example, and Lvl. So I will show you that right now. So let's see, I should have it in code somewhere. Actually, I think I have it open right now. Yeah, okay. I forgot I had it open before I started recording. So yeah, I wrote, if you're not familiar, Panda 3D is a game engine that uses Python. It's written in C++, but uses Python as a scripting language. And I wrote a parser to essentially go through, you can kind of see like, it goes through and finds what the test.json file that I have in here somewhere. I wrote like a level section. And a lot of it's collapsed. But you can see it, like all the things from my scene file. It's got a bunch of info on that, cubes, and then I got a little bit of everything in here. So like imagine if you had to write down all these things in Python code, which is Python shorter than like writing it in C++, but like still that's a lot of columns and stuff to write out. And then, you got the colliders and the spawns and a couple lights in there. So I wrote a parser that like it looks for models, loads those in, colliders, spawns, lights. I'm not going to go through all the code because that's just too much and not really what this is about. But if I open it up for you, you'll see. Well, let me fix the camera here and make it bigger. So you can see it doesn't look one-to-one with Blender because, well, Panda 3D handles lighting differently, but like the general location of where lights and stuff are at, I got a collider set up here, one around the sphere. I use these spawn points to, generate some smoke particles that like this is where they're spawning at. And then all the geometry is like located and rotated where it needs to be. I tried to add some materials to this, try to make this scene more interesting, and then I got lazy. But you can see that like I wrote a parser and everything is where it's supposed to be, and it works. It would have taken way more time to set up the scene. Granted, I did have to write all the code to parse through all the data and get it, looking like this, but that battery's low. Now that I have that code written, I can easily load Blender scenes like as a layout pretty quickly. And I will show you a similar example in Lvl. It's not going to look as nice because Lvl, you essentially have to write your own lighting, and rotations are a bit weird, so it was more of the test to see if I could get it loaded up, like, similarly. Let's see, build debug. So, yeah, as you can see, I didn't load any material. Like, Lvl doesn't have default materials, really, so if I kept them all the same, they would have been just, like, blended. You wouldn't be able to see anything. So I added random colors to stuff, which worked out fine, except for, you know, some of this gray. Like there's a column here that's blending in. You can only tell because the outline is overlapping with this. But yeah, for the most part, it laid out things. Rotations are weird, so some of the stuff is like either stretching, because you have to use transformation matrices, and I'm not an expert in that. And it was more of a proof of concept that, like, okay, I got it working in Panda 3D, let me try it in something else. If you know more about, you know, the mathematics of transformation matrices and shaders to set up the lighting, you could easily, like, recreate something that looks like Blender or the Panda 3D file I made. But, sorry, I didn't mean to yawn. As you can see, like, yeah, I wrote C++ code, and it worked there too, just a parser, and you got it up and running to, you know, get that all situated. So the layout became way significantly easier after I got the data from Blender. So yeah, that is essentially Lvl Exporter. It's a pretty simple tool. Just type a couple fields and hit XML and JSON, and you got your data. Thanks for watching.